Hi, everyone. Thank you so much for joining today's presentation on clean hydrogen markets. Give it a couple minutes for folks to sign in as per usual, so hold tight. And if everyone could please take a moment to make sure that they are muted until they're speaking. Thank you. All right, I think I'll give it 30 more seconds and then we'll kick off. All right, well, my name is Kate Harrison. I'm an associate on CEBI's Market and Policy Innovation team, if we haven't met before. My focus is on evolving market mechanisms to help customers procure the next generation of carbon-free energy technologies. So I'm quite excited to kick off our clean hydrogen work with today's educational session. We'll run through the agenda real quick, just a quick overview of how we'll spend our hour together today. Please feel free to put any questions you might have as we go in the chat, and they will be addressed at the end when we have the opportunity for an audience Q&A with the speakers. And I am so grateful to be joined by our speakers today. They're all quite knowledgeable in this space. We have Doug Miller joining us from our CEBI team here to give an overview of our work at CEBA and CEBI. We have Nabil, Bennouna, who manages climate-aligned industries work at the Rocky Mountain Institute. We have John Flory, who's speaking in his capacity with the Center for Houston's Future, working on their Hydrogen Hub initiative. And then we have Killian Daly, who's a general manager at EnergyTag, and he's joining us all the way from Brussels. So grateful to have you all. And I will kick it right on over to Doug to get started.
Great. Well, thanks so much, Kate, for kicking off the conversation. And thanks so much to everybody who's joined today. If we can go on to the next slide, Kate, please. So just to kick off the conversation before we have more time for the people you came to listen to, the panelists here. First, I'm just going to introduce the broader set of work that CEBI has underway to support next generation carbon-free electricity procurement and to support clean technologies. So for those who aren't familiar, earlier this year, the Clean Energy Buyers Institute, or CEBI, which is a 501c3 research nonprofit, we launched what we call the Next Gen Initiative. And essentially what the Next Gen Initiative is all about is how do we expand the menu of carbon-free electricity procurement options so that we can enable customers to send more targeted and powerful market signals with their procurement. In other words, how do we position customers to do more with their procurement and drive grid decarbonization? And essentially core to our approach is a four-part theory of change that includes: one, that we need to introduce enriched energy attribute certificates. In other words, we need to enrich and enhance energy attribute certificates so they contain more types of information. Secondly, and related to that, we need to introduce more granular and consistent data. In other words, we need the data that will enable these enriched EACs. We need new leadership programs to motivate and enable customers to set even more ambitious targets. And lastly, we need to make enhancements to greenhouse gas accounting to address lack in clarity and any gaps in accounting to accommodate next generation procurement. When we got started with this work, we put ourselves in the shoes of the customer because we're taking a user-centric approach and an agile methodology to develop the solutions for this space. And here's the list of the 8 things that customers want to be able to do that they can't readily do today. And the one we're diving into today is the notion of how companies want greater ability to procure any complementary resource and any carbon-free electricity resource. And so when we think about clean hydrogen within the context of this, of course, clean hydrogen can serve, for example, as a source of storage and so much more too. I won't dive into these other next generation objectives that customers have, but they are in many ways related. and at the very least synergistic with what we're diving into today. And for those who want to read more about each of those different objectives, earlier this year or earlier this fall, we published a guide that goes into depth about what each of these actually means and the market implications of solutions that deliver each. Also in the guide, just very briefly, essentially we go through what will it actually take to introduce solutions that achieve any combination of those 8 objectives. And essentially, we think there needs to be 5 new types of attributes added to the energy attribute certificate. We need the data to backfill those new attributes for these enhanced EACs. We need new leadership programs and/or updates to existing programs to incentivize next generation procurement leadership. And we go into the details of short-term versus longer-term updates to improve greenhouse gas accounting and accommodate and motivate next generation procurement. And I'm going to spend a little bit more on this slide because this is most relevant to today's conversation before handing the floor over. So earlier this fall, CEBI submitted comments based on our research to a couple of different public dockets, one with the US Department of Energy, one with the IRS, Internal Revenue Service, essentially all oriented around the incentives that are being unlocked through the Inflation Reduction Act or the IRA, the major federal incentives that may very well catalyze the clean hydrogen industry in the United States and potentially maybe indirectly abroad as well. And core to our comments are 3 main points that I'll highlight here. But just something at the very outset to say is our goal is to create a voluntary market for clean hydrogen, a self-sustaining market where customers can engage and where on one end, this helps drive further decarbonization of the grid. And it also promotes all the other non-electricity based components that clean hydrogen can support. And so the 3 main points are 1, we use stakeholders generally. This can include government folks and market practitioners. Stakeholders should require the use of market-based instruments around ensuring that the electricity that's powering clean hydrogen is in fact clean. So in other words, we need to make sure there's a relationship between and accountability in the accounting systems that shows that clean hydrogen is linked to an underlying energy attribute certificate. In other words, that we have the verification that the electricity is clean that's being used to power clean hydrogen. Otherwise, it's hard to substantiate those claims. Secondly, and building on the first point, we know we need, in order to create a voluntary market, clean hydrogen certificates or an EAC for clean hydrogen that essentially is linked and has synergies with the clean electricity EAC system, but that it enables a tradable, transactable instrument that can feed into so many different types of solutions that may come forward. And so there are some emerging standards being developed, I'd say more in the European context and in international renewable energy markets. But this is something we think is absolutely necessary in the United States to enable customers to engage in clean hydrogen markets. The last point that I'll raise before wrapping up on the last slide is there's an opportunity given all the attention, energy, resources going into clean hydrogen and knowing that this will create new local electricity consumption or load to drive greater next generation procurement. In other words, let's take the opportunity with all this money that's being given out as incentives to make sure that when we deploy clean hydrogen and we're linking with clean electricity procurement, that it's driving next generation procurement, whether that means in the local level, procuring carbon-free electricity, matching the load curve so that we can send those time-sensitive market signals, and or procuring carbon-free electricity at those most carbon-intensive times of day to send those types of market signals.
Great, thank you.
I think there's one more.
Oh, you're right.
And just in closing, moving forward on clean hydrogen and our general next generation procurement work, these are the types of stakeholders we're engaging. So we're working with EAC registries and issuing bodies to help them introduce these new attributes, data providers to get those data to backfill the new EAC attributes, leadership programs, the greenhouse gas protocol, and other stakeholders there, as well as the many solution providers who are trying to introduce next generation solutions. So with that, thank you so much and look forward to the discussion.
Thanks for that overview, Doug. I will stop sharing and give Nabil the floor.
Great, thank you. Give me one moment to share my screen here. All set?
All good.
Okay, great. Well, thanks for having me today. Just a quick overview here of what I'll be focusing on today. This is by no means a comprehensive list of all the opportunities and the challenges associated with the clean hydrogen industry, but some of the main talking points here for the conversation today. So on the opportunity side, some of this I'm sure will not be new information to folks, but just to level set, hydrogen's really the lowest cost pathway to decarbonize a few key sectors, and we'll get into those details in just a minute. And then there's also, through the IRA, some significant support that helps drive some green premium down to start getting a few of these key use cases in the money compared to their existing equivalents. On the challenges side, I think there are several supply chain alternatives for getting to a clean hydrogen, but not necessarily all of the incentives around making sure that the investments drive towards the highest priority projects with the highest potential to unlock overall system inefficiency, environmental attributes, opportunities for further scaling and unlocking new business models. There's also uncertainty around IRA rulemaking, and that adds risk exposure to certain projects, which can delay investment decisions, and we already see that happening. There are also near-term supply chain bottlenecks that may lead to reduce really the positive market signals you need to make investment decisions again. And those bottlenecks could be leading to sort of artificial price volatility for key materials and feedstocks, and could be skewing project and economics, which again could be delaying important decision-making to get shovels in the ground. And then again, this is one of the big societal projects, and we really need unprecedented cooperation between the public and private sectors, between competitors, and across different parts of the economy that haven't necessarily cooperated together before. And so eliminating some of those coordination failures across large entities that may have never worked together before, or at least at this scale, I think is a big part of the challenge. So I'll get into some of the details now. Again, why are we here? Why is important to level set? I think always like to start with why is hydrogen important? You see 5 key sectors representing 20% of global emissions. All of these 5 sectors really hard to decarbonize through traditional means. So even if you believe that, either way, they're going to require quite a complex portfolio of decarbonization solutions to get to net zero. Even if you believe that hydrogen is only responsible for 30 to 40% of the solution set to decarbonize these 5 key sectors, that's hydrogen still representing 7 to 8% of global emission reduction potential. So big opportunity, big part of the solution going forward. This is just another way of framing the 5 key sectors, the priority sectors here, 2 axes on this chart: technology readiness level and criticality of green hydrogen in the sector. And you can see again, the 5 major sectors I mentioned before, heavily represented on the top right of this chart in terms of both their technological feasibility, but also compared to other decarbonization alternatives, with, again, once you have these sectors up and running, could open up the door for other sectors utilizing hydrogen as well. Again, this is probably not new information, but just to level set, I think a lot of the topics on this call today are around the supply chains, and just wanted to level set the different types of routes to getting to hydrogen. Again, existing route, quote unquote, gray hydrogen, fossil based. Then another pathway that involves reducing the emissions intensity of the existing pathway by incorporating carbon capture, and then again, slightly different a supply chain associated with electrolyzers and getting to a more lower carbon intensity through electrolyzers and electrification. A little discussion here on the IRA and the support mechanisms that have been going to reducing the overall cost of producing clean hydrogen, and some of the sort of parameters around the provisions in the legislation. So I think we've set up here, there's a spectrum of support depending on the carbon intensity of the supply chain, everything from getting a full $3 per kilogram production tax credit, and that looks like 100% dedicated renewables, an example project that is 100% dedicated renewables with buffer storage. And then as the carbon intensity increases, the subsidy declines. And we have some sort of sample projects there where, for example, it's still quote unquote green hydrogen, but if you need to rely on some grid connectivity for balancing on a grid that isn't fully decarbonized, that carbon intensity will go up and the subsidy will go down. And then on the quote unquote blue sides, I think to even achieve this sort of middle of the road subsidy will require some very high capture rates all along the supply chain with very low methane leakage demonstration. And then again, the lowest subsidy with carbon capture at still very high rates with low methane leakage potential. So that's sort of the coverage of the IRA here. How does this translate to sort of demand signal? So I think pointed out some of the issues associated with ensuring that the entire supply chain is decarbonized, but if you are to do that, sends pretty strong signals for different major use cases. So for example, did some calculations here at RMI on 3 major sectors: shipping fuel, ammonia for fertilizers, and steel. And with the tax credit, I think you could see the resulting price of these main products being very close, if not beating the market price for fossil-based alternatives. And then especially with the DOE's objective of getting production costs down to $1 per kilogram for hydrogen, you could see that green alternatives for these major use cases being even further into the money. So I think lead to my conclusion here. What can organizations like CEBI do? I think Doug covered a lot of this already, but really pivoting to demand signals from commitments, so from sort of ethereal commitments to more solid, procurement. So essentially codifying strong demand signals by going to the second bullet here, by really pushing the discussion from a supply push to a demand pull. So creating very specific requirements on performance and value add to the system so that the supply side understands how to structure their projects. And then again, ensuring that folks know what they're even getting on the other side of the contract by establishing chain of custody for low carbon fuels. So happy to take questions at the end, but that concludes my comments for the moment. I can pass it over to John for the next part of the conversation.
Super, thank you, Nabil. Let me pull my slide up. Super. As Kate said earlier, I'm John Flory with the Alliance Risk Group, and today as a representing the Center for Houston's Future. I was brought into the Center for Houston's Future because of background in other energy market hubs, for example, helping to set up the California ISO and did some other stuff related to natural gas and power, the interactions. And so helping the hydrogen hub in the greater Texas Gulf Coast area to be a true market hub and not just a series of projects. I'm here today to share some experiences of the center in evolving to what is today is high velocity hub. It's a market hub. So I'm going to the topics for today in sharing these insights. Just a little bit of background on the Center for Houston's Future and why they're in the hydrogen area. Some discussion on a hydrogen roadmap that they had developed with McKinsey and how that led to some priority opportunities in the Texas Gulf Coast that I think will be insightful for people everywhere. Some of the elements of a successful ecosystem, not just demand and supply, but other key ingredients such as storage, delivery infrastructure, and the market infrastructure itself. And then finally closing about how to pull some of these insights together in terms of creating an easy button for the CEBI type clean hydrogen buyers. So the Center for Houston's Future has been in existence since the 1990s, but more recently in the late 2018, 2019, they started looking at what the potential world for Houston would look like as the oil and gas potentially took a less of a role in terms of reducing the carbon intensity, and the desire was to try to figure out how to have Houston become more of a global low carbon energy leader. And the 4 working areas were developed within a Houston Energy Transition Initiative. One was for carbon capture, utilization, and storage. One is just decarbonizing industrial assets, and one for today's discussion is clean hydrogen hub consortium, and then it's also capital and funding structures. And the CHF is particularly the lead on this clean hydrogen, and that'll be the basis of my next conversations. As part of moving that together, they've had a huge hydrogen steering committee, as have a number of other hydrogen hubs. There's about over 20 some entities who have submitted some proposals into the DOE to become hydrogen hubs from all over the country, and most of them have heavy stakeholder involvement. One of the things that the hydrogen roadmap developed with McKinsey revealed in terms of priority opportunities in the Houston Gulf Coast. The 2 big ones were the industry with particularly industrial feedstock because of the heavy use of refineries in that oil refineries in that space, and the role of hydrogen in that process, and also in export and the global events, and Europe's trying to reduce its sensitivity from Russian natural gas has helped explore this even further than when this project was initially done. But there are some things in this that I think particularly relevant for CEBI members. industrial heating, particularly steel. I know there's interest among CEBI members in decarbonizing your supply chain, and steel is often at a significant part of some of the products. Ground transportation, heavy-duty trucking, medium-duty trucking in particularly, as well as some forklifts inside facilities, utilities for power generation, balancing, and long-duration storage, and then even buildings themselves. And I guess one of the other things I should say is that today in the U.S., there's roughly 10 million tons a year of hydrogen that's used. About a third of that is in this footprint here, and so there's going to be a lot of just leveraging lessons learned here will be something that will be valuable across the country. The next slide just shows some of the key elements of a successful global ecosystem. We've already talked about demand, supply you've heard about in terms of both the blue with the natural gas and carbon capture and storage, as well as electrolysis for renewables for green. The thing I want to emphasize in this diagram is infrastructure and the trading marketplace. From an infrastructure perspective, hydrogen is significantly different than power or natural gas. For example, for your renewable power, you don't really have to worry much about whether or not you can get the electrons from one place to another. There's always a transmission and distribution system pretty much to handle that. That's not the case for hydrogen. You have 1,600 miles of hydrogen pipelines in the U.S. 1,400 miles of those are in the Texas Gulf Coast footprint, and so trucking, it must become more of a relevant distribution means. Also, because of the international interest in hydrogen as a way to reduce decarbonization, shipping becomes important as well. Again, for balancing supply and demand, storage is important. The Texas Gulf Coast area already has 2 hydrogen storage domes, geological domes, salt storage or salt caverns, and that's very helpful. Not every region of the country is blessed with such salt caverns, but there are the opportunity for using depleted gas reservoirs as well. And of course, these can be used for storing carbon dioxide as well as in some cases for hydrogen. And then we'll talk more about trading a marketplace as a way of bringing suppliers and buyers together more efficiently in a minute. Just as a quick point of reference, it feels almost like the Oklahoma land rush in terms of the number of projects that are starting to pop up at both blue and green in the Texas Gulf Coast area. The last thing I'd like to do is just take a minute to talk about creating the easy button for CEBI clean hydrogen buyers. The first, and has already been mentioned by Doug, and Killian's going to follow up more, is having a verifiable way to determine what the carbon intensity is, so we can justify the ability of using hydrogen for reducing the scope 1, 2, or 3 greenhouse gas emissions. And I'll just acknowledge that and say we see that as a cornerstone for a good market transaction, and hence the first point. My past experience and the perception of Brett Perlman, the CEO of the Center for Houston's Future, is that buyers often are the drivers of the hydrogen or any new market hub development. And so we see working with CEBI on clean hydrogen procurement as being very helpful for not only the Houston Gulf Coast, but also for the whole country. And we're tickled to see both the next-gen clean power procurement practices as well as the decarbonization of the industrial supply chain, which of course links back to steel. And so that's fantastic. The trading and marketing hub, I think the key thing that we've seen in that is allowing for options. We've had some people that have said that we aren't ready necessarily to pay the price for 100% green power, but if we can get a blend of green and blue, or even green and gray, then that makes it easier for us to move things forward. Finally, is that we've collaborating with other hydrogen hubs and other organizations to help move forward a national clean hydrogen network, which is the DOE's goal. We've had quite a bit of dialogue with California as an example, and some of the similarities. And a number of the normal national and global organizations that we've been in dialogue with are the Open Hydrogen Initiative, which is part of the Gas Technology Institute, GTI, RMI, the Hydrogen Fuel Cell Partnership, which is working on a hydrogen refueling network for medium and heavy duty trucking, probably starting with the California to Houston link. Mission Possible Partnership, which is an extension of a World Economic Forum activities. And I think that Killian's going to talk a little bit more about some European perspectives that the World Economic Forum is drawing from as well. So that's all that I have. Thank you all for your time, and I'm also happy to answer any questions, and I'll turn it over to Killian at this point.
Thanks, John. And Killian, I'll let you round us out.
Yes, great. So thank you very much for the opportunity. I will share my screen and present some slides. Yeah. So everything's good? Yeah.
Perfect.
Awesome. So thank you, first of all, to the other participants. Great context setting, and really interesting to hear about the projects going on in the United States. So yes, my name is Killian Daly. I'm the general manager of a nonprofit called EnergyTag. But before, maybe as a bit of context, before I joined EnergyTag, I worked in the hydrogen sector for 5 years in a company called Air Liquide, which is one of the major hydrogen producers in the world, and runs that Gulf Coast pipeline mentioned previously. So yeah, I'm quite familiar with the hydrogen sector. So coming at it from a new angle as well with EnergyTag, where we're focused on the hourly traceability of electricity. Just a quick word on EnergyTag to get you up to speed with what we're about, and then I will focus back on hydrogen. So we're a global nonprofit based in the UK, but very much has a global scope to enable hourly RECs basically around the world to increase the transparency and granularity of clean electricity claims. And yeah, very big focus also in the United States. Doug is one of our advisory committee members amongst some of the big utilities and buyers also there. So very much an EU-US initiative with a global expansion planned. And that, this new form of tracking enables more informed choice, more time-based choice of electricity, so you can make sure that you're securing clean energy every hour. And that is obviously really important for hydrogen. I'll come to that later on. Another key thing is that, time-based electricity choice incentivizes storage and flexibility, which are not really incentivized today with more annual approaches. There's various research on this. Happy to share some of that also afterwards to prove the benefits of this. So we have a standard for hourly tracking that we published at the end of March, and it's supported by these organizations. So a lot of big buyers, big utilities, and other major stakeholders from around the world who are supporters of our initiative, including CEBI. So to hydrogen, it's a topic we work on a lot at EnergyTag as well, particularly in the European context, and now more and more in the United States, as the US is looking to set its own accounting criteria for hydrogen. We believe that should be 24/7. First of all, I'll kind of take a step back and see where we are today with the hydrogen market, with some of the hydrogen standards that exist around the world today. This has been mentioned already. Just to recap, there's green hydrogen, which is from electricity, if that's green electricity, otherwise it's not green. And blue hydrogen, of course, is from CCS of natural gas. So they're the two kind of major options for the low carbon hydrogen future, and they've been covered already. I will focus more on the green hydrogen part because that's where electricity is involved, and that's kind of where a lot of the debate is really happening around these standards at the moment. With blue hydrogen, you capture the CO2, you sequester it properly. It's kind of less open to interpretation than some of the accounting methods we would use for electricity. So that's what I will focus on today. So obviously today, global demand for hydrogen is 90 million tons. It's mainly from refining and ammonia. They're the two big demand centers at the moment, and that's very much a fossil-based system at the moment, as we see here. It's gas, coal, and various chemical byproducts that are the feedstocks for hydrogen. Green and blue are what we need to decarbonize this hydrogen sector, which would obviously be crucial in a decarbonized energy future, as has been covered already. But it's still early days for these projects, and now is the time to set good standards. Once the markets ramp up, it's just really disruptive to change standards for industry. So good standards need to be in place early, and now is the chance to do that. That's some of the project growth. This is some stats from the IEA's hydrogen report. Obviously, we're still in the very early days of green hydrogen projects, but a massive expansion coming in the coming years. And obviously the United States will become majorly into the fold due to the tax credits and the Inflation Reduction Act. And really importantly, green hydrogen, it could be a massive driver for clean electricity production, clean storage. And that's something really important to keep in mind. It's a huge opportunity for clean energy also, because hydrogen is just a store of electricity. For example, if we were to produce all of the world's hydrogen today with green hydrogen, we need 4,500 terawatt hours of electricity, and that's more than the United States. So the orders of magnitude are enormous. We will need a lot of clean electricity to decarbonize the hydrogen sector. EACs, so energy attribute certificates, they enable these voluntary markets. It's absolutely crucial. They underpin everything. And that's basically what we need, right? Like for green hydrogen, we need electricity, energy attribute certificates that flow into hydrogen production and then produce hydrogen energy attribute certificates to produce that voluntary market that Doug mentioned at the beginning. This is, obviously the basis of this market, and it's really, really important to get right and to provide those proper market signals for both electricity and for hydrogen. And the quality criteria, so some of the things around temporality and deliverability, can hugely impact the quality of the hydrogen production when we talk about the electricity quality criteria, and I'll come to that in a minute. Just to give an example of the hydrogen standard that has been developed in Europe, it's called Certify. So there is an industry standard for hydrogen that was developed at the request of the European Union, basically the European Commission. It's an EU-wide system to issue hydrogen guarantees of origin, hydrogen RECs, hydrogen energy attribute certificates. Put together by, basically the who's who of the European energy and hydrogen sector. And I think a really good model that the United States could look to follow. And they have a green hydrogen certification and a low carbon hydrogen certification. So also one for blue hydrogen and CCS. And basically they have to meet 60% emissions reductions in order to get that GO. So that's, that's a really, really good example. It's a central EU registry also. But the volumes do remain low today. Happy to also go into that a bit more around volumes. The certifying mechanism is this, basically. It creates that hydrogen market with GOs. And of course, electricity guarantees of origin are required, and it's not linked physically to electricity or hydrogen flows. Currently, it uses an annual accounting method, and the European Union is actually setting new laws at the moment for what it means to be renewable hydrogen that will be stricter than this. And obviously Certify will update itself as the regulation changes as well. So just a word on what to think about as we think about tomorrow's hydrogen standards, as this sector starts to receive a massive amount of subsidy and a huge amount of growth. Probably stricter standards than we have today will be needed. That's just a quote I took from the Treasury Department and IRS consultation that closed recently, where they're asking about the quality criteria around time, location, vintage of instruments, whether they be RECs or power purchase agreements alongside RECs, if they're to be used for clean hydrogen production. It's really, really important to think of these. So some of the looser standards, when we look at time, location, and vintage here on the left, would be more annual, continental, or any asset, whereas some of the more strong standards now we're seeing in terms of how to ensure clean electricity supply, look at more hourly, local, and newer assets to ensure that really that hydrogen unit is being supplied every hour, everywhere with clean electricity. And that provides important new incentives. For example, storage. If you have hourly rules, storage has a role to play. If you have annual rules, it may not have as much of a role. And this is very much the strong criteria, by the way, That's what's currently proposed in the draft legislation by the European Union, and also for the US government, who have a 24/7 electricity target. It's important because of this. If you allow fossil electricity to produce hydrogen, things can get very quickly out of hand in terms of emissions. So if you take natural gas, produce electricity, and then produce hydrogen, you'll have 20 kilos basically of CO2 per kilo of hydrogen. So that's twice as intensive as grey hydrogen is today. So it's better just to use the gas directly in the SMR for efficiency reasons. So we really have to make sure every hour that we're getting truly clean electricity supply. And that really will enable a true green hydrogen sector. There's been some modeling done on this by Princeton University for the California 2030 case, showing at a system level exactly what I've shown on the previous slide. Having those proper stricter rules will, with time-based sourcing, will basically help ensure that we don't have adverse effects, and that green hydrogen doesn't end up actually producing more emissions than grey hydrogen, because we're calling on too much fossil electricity generation to produce that hydrogen. And again, that can come at a relatively low cost premium as well, as proven by this paper. So that's something quite important to keep in mind. And another point as well, obviously, if you want to look at blue versus green, etc., we need to make sure that that green hydrogen is actually delivering real world emission production, so that it's a level playing field between blue and green, blue and green hydrogen. So just a bit of a word about some of the accounting standards and policies around the world today for hydrogen. So the EU has targets for basically 10 million tons of hydrogen internally and 10 million tons imported by 2030. A lot of electricity there again, twice France. So it could be a massive boon for the clean electricity sector. And they're very, very ambitious targets. And at the moment, the European Union is proposing 24/7 local PPA rules for green hydrogen qualification. That's not final yet. That's coming in the coming weeks, but that's the current position of the EU. Obviously, the United States has the massive tax credit as part of the Inflation Reduction Act, up to $3 with very, very low intensity hydrogen, and the Department of Energy and the IRS have done consultations on this recently. The UK has a hydrogen standard already published, which does include 24/7 accounting. So there's a general, consideration and movement towards, time-based accounting to ensure green hydrogen production. And I'm sure many more governments around the world are going to be looking at their own standards in the coming years. So obviously the big one to follow next year and maybe the year after will be in the United States, to see how the Treasury and Department of Energy set the standards there to qualify for those tax credits, which will obviously define how this industry is built. So yeah, we have been doing a bit of advocacy in favor of 24/7 approaches for hydrogen. So that's a letter we recently sent to the European Commission, along with some industry players as well, asking for strong rules for hydrogen. And we'll be looking to do the same basically in the United States as well over the coming year alongside partners. And that is it from me. So please do reach out. There's my email. Our website has a sign-up form if you want to join our working groups to learn more about hydrogen, to learn more about clean electricity traceability. And obviously, contacting the folks at CEBI as well is a really good way to get in touch with us, as we work really closely. So thank you very much for your time, and now open up to any questions you might have.
Thank you so much, Killian, for that insightful presentation. I will ask all our speakers to come back on camera for audience Q&A, but before we do that, I'm going to launch a quick poll for our audience just to get a few insights on your all's interest. So that everyone could take just 2 minutes to participate in the poll, and then we'll move along to answer some questions. Just 1 more minute there. I know that there are longer questions. All right, if you haven't gotten those answers in, please do so, and then I will end the poll. And I see we have some questions in the Q&A chat here. Let's start with this question for Killian. So one of our participants asked, based on the experience with unbundled RECs, why would hydrogen ACs be critical to the growth of green hydrogen?
So if I understand the question correctly, what I'm not sure I fully understand, but what maybe I can give a bit of an idea. Obviously, what I've proposed is that first of all, if you don't have a contractual mechanism, if you don't have RECs, you just can't produce low enough carbon hydrogen that would ever from electricity in the United States. If you just use the average grid, nowhere basically you will be able to produce low enough carbon hydrogen to actually get the tax credit. And that's the same in the European Union. So market actors should be able to go out and contract clean energy to make sure that they're able to meet those emissions thresholds in a credible way, of course, in a way that actually drives real world emissions as well. And that's important as well for ensuring that every part of the United States has an opportunity to grow a hydrogen sector and not just certain areas. And then similarly, of course, once you've done that, once you've used the market mechanism for electricity, you need it also for hydrogen to ensure that there's a market signal basically for these green hydrogen certificates to drive that premium that folks need. I hope I've understood the question correctly.
And then just tacking onto that, someone just added, is there a proposal for green hydrogen credits?
Well, in the European Union, there's Certify, so that is a green hydrogen credit. That's a standard already in existence today. It's very clear how you meet those criteria. Obviously, the rules being proposed at an EU level to receive subsidy. So obviously, like the United States, Europe is going to be heavily subsidizing its hydrogen sector. They're asking for stricter criteria than the current industry standard to make sure that hydrogen delivers the reduction benefits and emissions that are expected. Once that is finalized, then the industry standards in terms of how that's implemented and how these credits are actually issued will change. So Certify would obviously update depending on what the European law is. In the United States, as far as I'm aware, there isn't currently a governmental standard for how the PTC credits will be received, and that's currently being developed basically. And obviously, once that is the case, then folks like the tracking systems for electricity or hydrogen can go about actually issuing these certificates. But maybe if anyone else has more information on that, please.
Well, at least in terms of the Houston, the high velocity hub, we see it being necessary to be able to tag the carbon intensity from source to production as critical. And because the tax credit requires the carbon intensity in terms of kilograms of carbon dioxide per kilogram of hydrogen, we see that as a doable thing, so that buyers of hydrogen through the hub should be able to know what the carbon intensity is and hence use that as a basis for whatever emissions reductions they want to claim.
Thanks for that, John. We have another question in the chat to known in particular, but for the group, which is the renewable pathway to produce clean hydrogen at the lowest cost and with the lowest emissions?
Kate, I'm happy to start us out with the response there.
Sure.
So I'd say, I know this is not satisfying, but I would say it really depends where. So if you think about the cost of production right now, 50% of the cost of production comes from the price of electricity. So I'd say first, and that's expected to, as the cost of the actual facilities goes down, especially electrolyzers going down, the cost of electricity is expected to become closer to 80% of the total cost of producing green hydrogen. So I'd say the first step is where can you secure the lowest cost PPAs? I think that earliest projects to the market will not be connecting into the into the grid necessarily, but there clearly will be low cost options to connect to the lowest PPAs through captive renewables. So that's one way to think about it. So wherever green hydrogen can be the lowest cost, assuming that you can secure very low cost renewables PPAs. Then if you think about other production pathways, specifically on the blue side, there is opportunity for price competitiveness in that pathway, but you have to consider some risk exposure to the project. So there is, what's your underlying assumption for natural gas pricing? So there's exposure to gas price volatility. And then also, if you're thinking about the subsidized cost, not the unsubsidized cost, you have to think about what is it going to cost the project to attain the production tax credit. So what is going to be the cost of determining the carbon intensity, the measuring carbon intensity across the entire pathway? And so I know, again, that's unsatisfying, but it really depends on the risk tolerance of the project. And if for example, rulemaking isn't strong enough around measuring carbon intensity, then sort of natural gas-based production pathways might end up being lower cost because there is no price associated or a lower price associated with certifying the carbon intensity of the entire pathway. And then one more, sorry, I don't mean to hog the microphone here, but in certain instances, like in Europe, it might be the lowest cost pathway might be the import route. So depending on relative subsidies in different production regions, you might see an import product being competitive with local product. So based again on the cost of electricity and other supply chain parameters.
Something maybe just quickly to add is, I think, Nabil, you focused in a way more on the supply side and the costs on that, bringing costs down there. I think there's a synergy on the demand side in terms of if we deploy solutions that customers can procure, then one, that helps secure the knowledge that there will be off-takers, there will be uses for the ultimate production, and you have those types of dynamics in terms of attracting more investments in clean hydrogen, which of course has that snowball effect of then helping bring costs down, just like what we saw in the renewable space. And then secondly, this whole point about creating market instruments are a source of revenue, and that would help make clean hydrogen more profitable than it otherwise would be. And so that also is something to consider in terms of the overall cost benefit analysis of clean hydrogen and its potential, especially at the early stage where there might be interest among some in a premium, considering, say, compliance with things like the European Carbon Border Adjustment Mechanism, the CBAM.
Killian, did you want to jump in there? Are you good?
Yeah, I think it's just kind of to echo a lot of what Nabil mentioned. Clearly, the only electricity, especially in the long run, that will, I think, ultimately be cheap enough to make green hydrogen competitive is clean electricity. Definitely in Europe, because we have now a massive gas problem here. It's super expensive. It's driven up electricity prices everywhere. At today's electricity market prices in Europe, it would just be impossible to produce hydrogen competitively from purely the grid. So you need to access low cost renewables. And that also fits well with, actually, funnily, with the lowest carbon pathway. So if you really ensure that you're getting clean electricity delivered every hour, you're less exposed to really volatile and uncertain spot market prices set by gas turbines. So, there's actually a narrative here where we need to build a hydrogen sector that is both low emissions and avoiding spot markets that are heavily influenced by gas. And we should be building hydrogen storage so that basically we can be consuming when those renewables are available, and not having to rely on grid electricity as much when they're not, if you do need baseload supply of hydrogen. So I think it's really important to keep that in mind. It's all about clean electricity pricing every hour as well, because otherwise the costs of hydrogen can just get quite out of control.
I have a comment to weigh in on this. There's clearly the clean electricity is over the longer term is the most clear path forward. In the near term, blue hydrogen and reducing the carbon intensity in the existing delivery process is something that can help us reduce our overall greenhouse gas footprint. And as the scientists have told us, time is of the essence. So we need to focus in the next 5 years as well as the next 10 years and beyond. And so we see trying to take advantage of reducing the carbon intensity of the existing natural gas driven hydrogen production process is something that's key, and as we see that as a way to blend in to both reduce the cost of a portfolio that includes some green hydrogen as well as drive down the carbon intensity of the existing natural gas driven process.
Thanks for such a thorough answer, everyone. It was a great question. I have one more quick question, hopefully to round us out, and then I'll share the poll results and we'll conclude. So clean hydrogen is obviously experiencing a bit of a renaissance now, but it is not a novel technology or fuel source and has rather unsuccessfully taken off as a trendy fuel source in the past. I'm curious why this time is different. If anyone wants to take a swing at that, and then we'll call it.
I think this time is different because of people like CEBI members who take greenhouse gas reduction seriously, and we haven't had such a demand pull in the past, and that along with the things like the production tax credit of the bilateral infrastructure law, those two together I think make this a significantly different time than any time in the past for moving towards a lower carbon intensity hydrogen.
Maybe just briefly to add to John's comments, and it's not necessarily different, but just hammering home the point. It's decarbonization as U.S. federal industrial policy, and the emergence of the U.S. having an industrial policy that overlaps with decarbonization, and of course, all the new incentives around that.
Good answers. Thank you all. And here are our poll results. All right. And with that, I want to thank you all for joining. I want to thank our speakers for taking the time to participate. And all the information they're able to share. I know I got a lot out of it. I hope you all did too. And have a wonderful rest of your day. Bye, everyone.
Thank you.
Thank you.